Hey everyone, and welcome back to the channel. Today, we're diving deep into a fault code that can be a real headache if you do not know where to start. SPN 190 FMI-II. If you've ever seen this code pop up on your heavy equipment diagnostic screen, you know it's related to the engine oil pressure sensor. But what does out of range or data erratic, intermittent, or incorrect actually mean? Let's break it down. Essentially, this code tells you that the engine control module, or ECU, is getting a signal from the oil pressure sensor that just doesn't make sense. It's not that the pressure is too high or too low, but rather that the voltage reading from the sensor is erratic or illogical. For example, the ECM might see a voltage that's jumping all over the place, or a value that's impossible under the current engine conditions. This isn't a simple low oil pressure warning. It's a signal that the sensor's communication is faulty. So, where do you begin your troubleshooting? The first and most common culprit is the wiring. Start with a thorough visual inspection of the harness connected to the engine oil pressure sensor. You're looking for any signs of damage, chafing, rubbing, burnt spots, or corrosion on the connectors. Heavy equipment operates in harsh environments, and vibrations and heat can take a toll on wiring over time. Pay close attention to where the harness is routed, especially near hot exhaust components or sharp metal edges. Don't just look. Gently wiggle the wires and connectors while the engine is running, if it's safe to do so, and see if the fault code becomes active or inactive. This can help you pinpoint an intermittent break in the circuit. If the wiring looks good, the next logical step is to suspect the sensor itself. Engine oil pressure sensors can and do fail. They can develop internal faults that cause them to send these erratic signals. One way to test this is by checking the sensor's reference, voltage, ground, and signal wire right at the connector. You'll need a multimeter and the correct wiring diagram for your specific machine. Typically, you should see a stable 5-volt reference and a good ground. The signal voltage will vary with engine oil pressure, but it should be a steady, predictable reading, not a fluctuating, nonsensical one. But hold on. Before you rush out to buy a new sensor, there's another crucial step. What if the sensor and wiring are both fine? The problem could be mechanical. It's possible that the actual oil pressure is fluctuating wildly, causing the sensor to send an erratic signal. This could be caused by something as simple as an oil filter relief valve sticking, or something more serious like a failing oil pump or excessive bearing wear. A good way to verify this is to install a mechanical oil pressure gauge. Tee it into the same port as the sensor, or use another available port. If your mechanical gauge shows a steady, normal oil pressure, while the electronic sensor is still flagging the code, you can be pretty confident the issue is electrical. If the mechanical gauge needle is bouncing around erratically, then you've got a much more serious internal engine problem to investigate. Let's recap the diagnostic path. First, inspect the wiring harness for any physical damage, paying special attention to routing and connection points. Second, test the sensor's electrical integrity. Check for proper voltage, ground, and a stable signal. If you suspect the sensor, a good next step is to swap it with a known good one if you have it. Third, if the electrical side checks out, confirm the actual mechanical oil pressure with a manual gauge. This will definitively tell you whether you're chasing an electrical ghost or a real mechanical problem. Often, it's a simple wiring fix or a bad sensor, but following these steps methodically will save you time, money, and a lot of frustration. Thanks for watching, everyone. We hope this guide helps you tackle SPN 190 FMI-II with confidence. If you found this video helpful, give us a thumbs up. Drop a comment with any questions, and don't forget to subscribe for more heavy equipment diagnostic tips. Stay safe out there, and we'll see you in the next one.